let's have a look at recording data. Now along the way we're going to visit a few words that might be new for you. We're going to start by doing that with the words observation and inference. Now these words are related, but they're not the same. An observation is based on factual sensory information. It's something that you experience directly through one of your 5 senses of sight, hearing, smell, taste, and touch. An inference, on the other hand, is a conclusion that you reach after an observation. For instance, here's a photo of a lady. Now, we can observe that there is a woman in this photo. We could infer that she's a businesswoman because she's wearing a suit and got an iPad or some tablet with her. She looks quite professional, so we could infer that she's a businesswoman. Is she actually a businesswoman? We have no idea. So we can infer that. We could make that conclusion about her. But the observation is that here is a photo of a woman. She's wearing a suit. That's the actual observation. Here's another photo. Now we can observe that there's a man in a kayak. We can make the observation that there is a shark. We could infer that the man might be worried. We can't observe that. That's just what we think. From the observation, we make the conclusion that the man might be worried. One more example. Here is an image of some penguins. Now we can observe that there are 8 penguins in this photo. All right, we can easily count them up, no problem at all. We could infer that maybe the 7 still on the ice actually pushed the other penguin off. We didn't see that, we didn't observe it by looking at this photo, but we could infer that. We could infer that the other penguins are also going to jump into the water after the first one. It's not an observation we can make, but we can make that conclusion that all the penguins are about to jump into the water. So that would be an inference. We infer that. The observation is that there are 8 penguins. Another observation is that one penguin is about to enter the water. So an observation is based on factual sensory information. We literally observe it with our senses. And an inference is the conclusion that we reach after an observation. Let's look at a different couple of words, qualitative and quantitative. Now, when recording data, our observations that we make could be either of these. They could be either qualitative observations or quantitative observations. Qualitative means you observe and describe. For example, the liquid turned red, or the test tube felt hot, or a scent of apples was given off. These are qualitative observations. Quantitative, on the other hand, means that you're going to measure something. Think quantity, right? How much do you have? So quantitative, you measure. For example, it took 3 minutes for the reaction to complete, or the ball bounced 56 centimeters in height when I dropped it from 1 meter, right? These are measurements that we've taken. These are quantitative observations. Now, when quantitative data is being recorded, the units are actually very important. For example, if you're recording mass, it's not good enough to have your answer as 32.1. Like, what are you talking about? Is that 32.1 grams? Maybe it's 32.1 kilograms. Maybe for some strange reason you were talking about 32.1 trees out in the playground. Like, who knows? You didn't tell me. The correct units must be specified. Moving on. When water and other liquids are in a container, there's an attraction called adhesion between the water molecules and the sides of the container. So this causes the water at the edges, the part of the water that is actually against the sides of the container, to be higher. This gives the surface of the water a concave shape, and this concave curve on the surface of the water is called a meniscus. Something else we should take note of when recording data is that of parallax error. When reading off a scale, we need to be careful to read the scale at right angles, perpendicular to the scale. If observing the scale at an angle, we could get parallax error, and this could lead to a false reading. In the case of reading the volume of water or other liquids, we read the scale at the bottom of the meniscus. So in this example, we can see here, the true volume is 19.70 mils. But if we read not from perpendicular, but from a bit higher, looking down on that, we get a reading of 19.62 mils. If we read from lower than perpendicular, we get 19.82 mils. So we need to be careful when we're taking measurements like this, that we would either raise the, well, in this case, the measuring cylinder, or we would lower ourselves. We're not just going to look down on it when it's sitting on the bench and make the measurement. We either lower ourselves to be perpendicular to the level of the meniscus, or we would raise the measuring cylinder. Of course, if you just picked it up, that could bring in more error, that the measuring cylinder might be on a slight angle. You might be holding it on an angle and not even realizing it. So we just need to be careful of parallax error.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!